Hi guys, Mrs. Rossi here. Today we're going to be talking about properties of solutions. I want you to follow along on the note sheet that you got in class, and if you need to pause or go back or anything like that throughout the presentation, make sure you do it. All right, so first up, we need to know what solubility is. The solubility of a substance is the amount that dissolves in a given quantity of solvent at a given temperature. So all this means is if I put this solute in this solvent, how much of it will actually dissolve? And remember, when something dissolves, it is no longer visible, so it doesn't clump up at the bottom. You don't see the little particles floating around in the solvent anymore. It's just totally in there. You can no longer see it. Think like salt water. You can't see little pieces of salt floating around in the water, but you know it's in there. So there's a couple different factors that you need to be aware of that affect how soluble something actually is. These are your four main factors. So the nature of the solute and solvent. Remember what we talked about last time, like dissolves like. So if you have a polar solute and a polar solvent, it will dissolve. If you have a nonpolar solute and a nonpolar solvent, it will dissolve. But if you have one and one, then it won't dissolve. So like dissolves like. Agitation is the second factor that affects solubility. So agitation just means stirring, mixing it up, getting more kinetic energy in there to get it to dissolve faster will help things dissolve quicker. The temperature of the substance, so the more heat energy it has, the quicker it will dissolve. This is probably something that you've seen in real life too. And then particle size, depending how big your starting particle size is, the larger it is, the tougher it will be to dissolve. The smaller it is, the easier it will be to dissolve. There's a couple different types of solutions when you are dissolving stuff in them. The first is a saturated solution. A saturated solution contains the maximum amount of solute for a given amount of solvent at a constant temperature. So saturated solutions are totally full of solute. You can't fit any more. It won't dissolve if you put any more in there. Unsaturated solutions are the opposite, so they haven't reached that max out point yet. They contain less solute than a saturated solution. So if you put more solute in there, the solvent will be able to continue to dissolve it. And then our last type is a supersaturated solution. And in this solution, it has more solute than you would think possible, usually because temperature has been manipulated in some way to get more solute to dissolve in there. All right, so here's a couple examples for you. In an unsaturated solution, you can add more and more solute and it will continue to dissolve. In a saturated solution, you can't fit any more solute, so it's going to no longer dissolve it. You're at that maximum amount. And then supersaturated, we know that temperature has been manipulated in some way. You're going to start to see crystals growing. This whole saturated, unsaturated, supersaturated thing actually applies to us in real life. We know droughts are sometimes a problem in the US and also around the world, and this guy is going to tell you how they're trying to solve that using this supersaturated and saturation type of solutions.
A rapidly growing population coupled with global warming means that water is increasingly set to become the world's most precious commodity. One of the solutions to this problem can be found within clouds.
An average rain cloud contains about 8 million tons of rainwater, and therefore there's a vast quantity of untapped fresh water in the sky, and this is where cloud seeding comes in, to address the growing needs for water around the world.
Most rainmaking techniques used today originated back in 1946, when scientists discovered that by dropping particles of a chemical called silver iodide into cloud tops, they could trigger rainfall. Since then, countries all over the world have experimented with different ways to squeeze rain out of the clouds. China spends more on cloud seeding than any other country in the world.
We'll put the radar on. Here are the aircraft, so you can find out the distance and telephone. Yeah, if you can see what the distance is, that would be...
Dr. Brunjis is in Mali, West Africa, to test out a new technique he's devised with colleagues at the National Center for Atmospheric Research. It involves the use of pyrotechnic flares to deliver a special seeding material into the base of a cloud.
These are the so-called hygroscopic flares. They consist of salts inside. And as we burn them, the smoke produces the particles, the salt particles, that will then be taken up into the cloud and participate in the rain formation.
Once released into the cloud's updraft, each one of the hygroscopic salt particles becomes a seed around which a single water droplet can form. These droplets collide with each other and grow, eventually becoming heavy enough to fall out of the cloud as rain.
Oh, there's a rainbow up front here.
Weather modification today is an increasingly precise science which can reap huge benefits for the many countries that suffer from severe water shortages.
In the last few years, we've literally been on all 5 continents. A lot of our work focused on Southeast Asia, Africa, North and South America, and then also in Europe, Italy and Greece. There are currently more than 47 countries, more than 150 programs, cloud seeding programs, going on as we speak.
Ron, you can go back.
Cloud seeding seems to be making a change for the better for many people in the world today. But it's a science that is born out of a murky and troubled past.
All right, so kind of interesting to see what they do to combat droughts and how they use different types of solutions to make those clouds actually rain when they need it. All right, so we already know that temperature affects solubility. This is something that you probably already know and probably already seen in real life. The warmer a substance is, the easier it will dissolve whatever solute that you're putting in there. Think iced tea versus hot tea. Iced tea, you're going to have to stir a lot more to get those sugar crystals to dissolve in there, where in hot tea, it will dissolve more readily. Definitely be a lot easier to dissolve sugar in your hot tea. All right, so concentrations of solutions. The concentration of a solution is a measure of the amount of solute that is dissolved in a given quantity of solvent. So how strong something is. So when you put sugar into your tea, do you put a little bit, you would have a low concentration, or do you put a lot, you would have a high concentration. And you can actually calculate it, and that's what we're going to be practicing doing in just a little bit. There's different names for how concentrated a solution is. A dilute solution is one that contains a low concentration of solute. A concentrated solution is one that contains a high concentration of solute. So if you think Kool-Aid, pretend those glasses on the bottom are Kool-Aid. The one all the way on the left is very diluted. There's not much Kool-Aid in there. The percent concentration of Kool-Aid versus water would not be a big number, and that is considered to be diluted. Where on the other hand, on the right-hand side, we have a very dark red, a very, very strong Kool-Aid drink. So it would have a very high percentage of Kool-Aid to water, so it would be considered very concentrated or a very high concentration of Kool-Aid in that drink. We can actually calculate the concentration. So let's say this is our fruit juice drink that we want to have for breakfast, and we want to figure out how much sugar is actually in there. There's a couple of things that you need to be aware of. The serving size first is one of them. So if you're going to have this whole fruit juice drink and you want to figure out how much sugar is in it, you better be aware of the serving size. This one, for example, has a serving size of 8 ounces, but there's two servings per container. So our total serving size or total consumption is going to be 16 ounces if we drink the whole drink. The other thing we have to be aware of on these nutrition facts is that different units are used. So our size of drink is given to us in ounces, but our sugar amount, what we're interested in figuring out, is given to us in grams. So we're going to have to do some conversions. The basic formula to figure out concentration is the amount of solute divided by the total volume of the drink times 100 gives us our percent of whatever we're looking for. But we need to make sure our units match. So the first thing we're going to do is figure out how many grams total are in this drink. You're following along on your paper. We're down at number 11. So our serving size is 8 ounces, but there's 2 servings in the container. You're really thirsty, you're going to drink the whole container, so you're going to drink all 16 ounces. 16 ounces is great, but we need to know how many grams that is because our sugar was given to us in grams. So 16 ounces times 28.3495 grams, because that's how many grams are in 1 ounce, gives us 453.592 grams of our total drink. Now remember, the nutrition facts are only for one serving size. So our grams of sugar that we're going to be consuming need to be doubled too. So that's why it's 2 times 25 grams of sugar, because of the 2 servings that we're going to be consuming, over the total drink, which is 453.592 grams. When you do that, it will be 50 divided by 453.592 times 100 gives us 11% sugar. So this drink is concentration of sugar is 11%. All right, what I want you to do, and now you're over on the back of the paper, is think of your favorite drink other than water. Can't pick water. I want you to look up the nutrition facts on your phone, make sure you're aware of the serving size, and I want you to calculate the concentration of sugar in your drink. I added some helpful conversions on here for you to use just in case. Remember, your units have to be in the same amount. So if you want to convert to grams like we just did, do it. It's probably the easiest way to go. So for number 12 on your paper, you're figuring out the percent concentration of sugar in your favorite drink. And then I want you to brainstorm, and you can talk to the people around you, try to come up with the sugariest drink and calculate the percent of sugar in that drink. So look up the nutrition facts once again, make sure you are aware of the serving size, make sure you're aware of the units, you want to be in the same units, and calculate the concentration of that as well.